Hello, and welcome to the video notes for lesson 4.1. Back in chapter 3, we learned all about linear equations, and it was just one linear equation at a time and how it was maybe crossing the y-axis or x-axis and how it looked visually. And now in chapter 4, we're going to involve a system of linear equations, which means first we're going to look at where we have two equations together, and then we're going to add a third equation in 4.3. So we have three possibilities. We have case one. Case one is where the two linear equations intersect at a single point. And then they go on their merry ways. This is what usually happens. Case two is where the two lines are parallel. They have different y-intercepts, but they grow or decline at the same rate. Case three is where the two equations actually coincide. They're actually the same graph, but we didn't know it. And you'll see how that might be explained in a different kind of context that I will use. So let's say you were told that you have a total of 6 coins that can only be dimes and nickels. We also know that they have to total to be 50 cents. How many of each coin do we have? This is a question where we would use a system of equations to solve this, because we could have an equation of dimes and nickels that only involved the number of coins. We know that the number of dimes and the number of nickels equals 6, so the number of coins. Coins is our unit. But then that's equation 1. Then we could have equation 2 that would also involve dimes and nickels, but it's going to be the value. Okay. And so that would be the value of a dime is 10 cents times the number of dimes we have, plus the value of a nickel, which is 5 cents, times the number of nickels we have, equals 50 cents. Okay. And we, with our understanding of money, we could probably do some guess and check to figure that out. But first of all, if we treat this as X and Y, we could actually go to Desmos and see what this might look like. There we are. Okay. So if I have X plus Y, I'm going to turn off my graphs down here. If I have X plus Y as a number of coins, that's graphed here. And then I have the value of the coins graphed. We can see if we click on either one of the graphs, we can see that that intersects when we have 4 dimes and 2 nickels. That gives us 50 cents. So we can see it graphically. So if you look on your paper for example 1A, it says graph the following in Desmos and see where they intersect. And you can see here on my screen, I have the first equation, 5x minus 2y equals 10. I'm going to hit the graph to turn on the graph there. And then x minus y equals a negative 1. And I'm going to touch that graph. And you can see that they intersect at one point. And if you touch either graph, I'm going to touch the purple one, it will show me the intersection if I hover over the intersection point. And so what I'm going to want you to do throughout this chapter and on the test even is I want you to use Desmos and I want you to find the intersection visually. And then you're just going to use your algebra skills to work backwards, because you're growing in your concepts of symbols and algebra with a visual concept. So on our paper, we're going to write 4, 5. Now, if you look at example 1B, I'm going to first turn off these graphs and close that folder. And I'm going to open up 1B. And you can see the second example is the equation y equals 1/2 x minus 2. I'm going to turn on that graph. And then the second equation is 2x minus y equals a negative 1. And I'm going to turn on that graph. And again, we can click on either of the graphs. I'm clicking on the green. And it looks like they intersect at a negative 2, a negative 3. And we can show by substituting in a negative 2 and a negative 3 that they both equal the same value. So you can see in the second equation here, I inserted a negative 2 for x and a negative 3 for y, and that comes out to be a negative 1. And if I go up to my first equation, and if I put a -2 into my first equation, I get a -3 for the output. And so that's how we know that they equal each other. We can see it visually. I'm going to turn off those graphs for a minute. So let's go to our paper. So you should have noted the intersection points here. So if you flip the page, you're going to learn one strategy. There's going to be two, but we're going to learn one that's called the addition method to solve for x and y. So it says to solve a system of linear equations by the addition method, we're first going to decide which variable we want to eliminate. Yep, we're actually going to eliminate a variable. Step 2 says use the multiplication property of equality on each equation separately to make the coefficients of the variable that is to be eliminated opposites. So we want them to be the same value but opposite. So like a -2 and 2, because a -2 plus 2 adds to 0. And 0 is what we mean by eliminate. Step 3 says add together the respective left and right sides of the system, and that variable that you chose to eliminate should be gone. Solve for the remaining variable. Step 5 says to substitute the value of the variable from step 4 into an equation containing both variables, so one of the original equations, and solve for the other variable. And then you're going to keep repeating that to solve for both x and y. And then you're going to check your solution in both equations to make sure it's true. If necessary, you can also look, I recommend looking in Desmos because that will validate. So let's look at example 2. Solve by following the system. Solve the following systems by addition. So I'm going to choose to eliminate x because x in both equations has a 1, a -1. So the ones just need to make one of the rows positive and the ones will add to 0. So I'm going to say a negative of row 1. Notice that I'm telling what I'm doing, my action, and I'm telling what row I'm doing that to for directions. So that means I'm going to have a positive x, a positive y, and a -4. And I take the negative of row 1. And then I'm going to mark row 2 is staying as is. So I'll have a -x plus 2y equals a -3. Now I'm using step 3 from up above that says to add together the respective left and right sides of the system. So when I add them, those add to 0, they eliminate, which is what it's called. And then we have 3y equals a -7. And then we will divide by 3. To get y equals a -7/3. And then I can put a -7/3 back into either equation. So I'm going to put that back into row 1. So a -x minus a -7/3 equals 4. And then using our strategies back from chapter 2, we are going to multiply through by that denominator of 3 to make it so there's no fractions. So I'm going to have a -3x plus 7 equals 12 when I multiply each term by 3. Now I can solve for x. So subtracting 7, this is what we did back in chapter 2. A -3x equals 5, and dividing by -3, I get a -5/3. So I believe that these two equations intersect at a -5/3, comma, a -7/3. And we are going to go to Desmos to check that out. And that is 2a. So I'm going to click the two graphs. I'm going to click on that and I'm going to go here. And you can see that a 1.667 is the negative 5/3 and negative 2.33 is the negative 7/3. So we were correct. And I validated 1.66 here. And then I can just put that into fraction form and check that out. Okay. Then back to example 1, we're going to go back to our paper here. Back to example 1. Says 5x minus 2y equals 10 and x minus y equals a -1. And so we already did this on the first page just with our graph, right? So we want to show algebraically that it equals 4, 5. And I could decide to eliminate either x or y because I could just multiply the second row by -5, and then the rows would add to 0 on the x's. Or I can multiply the second row by -2 and my y's would add to 0. So I'm going to choose to eliminate y this time. For no other reason than last time I think we eliminated x first. So that means I'm going to leave row 1, 5x minus 2y equals 10. And I'm going to multiply row 2 by a -2 times row 2. So that will give me a -2x plus 2y equals a +2. Make sure all terms in the row get multiplied by -2. So my y's do add to 0. I end up with a 3x equals 12. And when I divide by 3, I get x equals 4. Then I'm going to put x equal to 4 into row 2 just because it looks a little easier. So 4 minus y equals a -1. I'm going to subtract 4, and we get a -y equals a -5. And taking the opposite of y, because I want y to be positive, I just take the opposite of 5, and I get 5. So indeed, I do validate that my answer is 4, 5. And we already found that on the graph earlier. Okay. Now let's solve by using elimination for part C. We can see that 6 is a multiple of 6 is a multiple of 3 by 2. So I'm going to multiply, and I need them to be opposite signs. Ooh, it looks here that the y's are already opposite signs. And 4 is a multiple of 2. So I'm just going to multiply row 1 by 2. So I'll get a -6x, -4y equals a -2. And then I'm going to keep row 2 as is. A -6x plus 4y equals a -2. So that worked out well. My y's cancel. I end up with a -12x equals a -4. And I divide by a -12. So I get a +1/3. And then I'm going to put that back into row 1. So x equals a +1/3 minus 2y equals a -1. And that's nice because the 3's cancel. We have a -1 minus 2y equals a -1. And then I'm going to add 1 to both sides. And we get a -2y equals 0. And dividing by a -2, we get y equals 0, which is okay. So it looks like they intersect at 1/3, 0. And let's just validate that by going to Desmos to check it out. We already have Desmos pulled up, so there's 2C. I'm looking at the two graphs, and I'm going to click on either one of them and see that, yes, indeed, they do intersect at 1/3, 0. I'm going to turn those off. Okay. Letter D is going to be on the extra video. So I'm skipping D because that's on the extra video. We're going to learn the second method for solving a linear system equation, and that's called the substitution method. And that's by taking either of the equations and solving for x or y. So you're going to put x in terms of y or y in terms of x. Okay, you don't have to manipulate anything if you've already been given one of the equations and x in terms of y or y in terms of x. You're then going to substitute that expression for the variable obtained in step 1 into the other equation and solve. Substitute the solution from step 2 into any equation of the system that contains both variables and solve for the second variable. And then, of course, check your results if necessary. So, let's look at an example. Example 3, we did this example back in example 1, remember, in our Desmos. So you can see here that I already have a recipe for y. It's 1/2 x minus 2. So I can just substitute that into the second equation into y. So I can take this information. I know how to make y by doing 1/2 x minus 2, and I'm going to put that here into y. And that's my row 2. So row 2 is 2x minus, and then I'm inserting this 1/2 x minus 2 equals a negative 1. And this is for me kind of like when I'm making a recipe, and if I don't have eggs, sometimes they say you can use applesauce works. That's just taking one ingredient and substituting it for another ingredient. So we're going to distribute the negative here. So we have minus 2x and then plus 2 equals a negative 1. And then I'm going to multiply through by my denominator of 2 to eliminate my fractions. So I have 4x minus x plus 4 equals a negative 2. Remember, everything gets multiplied by 2, each of my terms. And now I can combine them. So we have 3x plus 4 equals a negative 2. Subtracting 4, we get 3x is a negative 6. And dividing by 3, we get x is a negative 2. Then I'm going to put x is a negative 2 into y1. And solve for y. So I get y is a negative 3. So just like we verified visually in Desmos earlier, the answer is a negative 2 and negative 3. So we have row 1 and row 2 says that I can make y by taking 6x plus 3. So we're going to substitute that in to y into row 1. 3x minus 6x plus 3 equals a negative 8. Again, distributing my negative. 3x minus 6x minus 3 equals a negative 8. And then getting like terms, I have a negative 3x minus 3 equals a negative 8. I'm going to add 3 to both sides. We get a negative 3 equals a negative 5. And then I'm dividing by negative 3. So x is a positive 5/3. And that's now going to go into row 2 to find y. So y equals 6 times 5/3 plus 3. It goes into 6 2 times. So 2 times 5 is 10. 10 plus 3, y equals 13. So I have a solution of 5/3 and 13. You can check that out in Desmos. I've already done that one. And letter C. we again have a recipe for y by taking 5/4 x. And we're going to substitute that into row 1. So row 1 and -10 is 5. Oh, we're substituting that in for y, sorry. Row 1 and -10x plus 8 times 5/4 x equals a -6. We have a -10x, 4 goes into 8 twice, so plus 10x equals a -6. And we have a -10 plus 10 eliminates my x's, so I have 0 equals a -6. And that is an untrue statement. And that goes back to the parallel. They're parallel lines because it's an untrue statement. That means they never touch. So there's no solution. So there's no solution because you can say they are inconsistent with one another. So inconsistent. And then letter D is on the extra video if you want to check it out. Catch me back for lesson 4.2.